This is lesson 6.2, solving systems by elimination. In the last lesson, we were introduced to systems of linear equations, which is two or more linear equations with the same variables, and we learned how to find the graphical solution to a system by graphing the lines and finding where they intersect. We learned that there's three possibilities for how many solutions there are: one solution, no solution, or infinite solutions. Today, we're going to learn how to solve systems by an algebraic method called elimination. Solving systems by graphing can take a lot of time because you have to set up the graphs, and it's also error prone. Sometimes the lines don't go exactly through the grid lines, and you just have to estimate what the solution is. So thankfully, there's actually two other methods to solve systems of linear equations, and they're both algebraic methods. Today, we'll learn elimination, or it's called addition in the workbook. And then in the next lesson, we'll learn the other method, which is called substitution. Listed out are the steps of how to solve systems using elimination. First, you're going to write the two equations in the same form, one stacked over the other. Ensure that the x terms line up, the y terms line up, and the constants line up. So in this example, we have our two equations, but they're not quite in the same form and they're not lined up. So we'll rewrite them so that we've got negative x, we'll bring the x to the other side, plus y equals 4, and then that will line up with the bottom equation here. So the x's are lined up, the y's are lined up, and the constants are lined up. The second step is we're going to multiply one or both of the equations by a number so that either the x terms are identical or the y terms are identical. So given these two, if I multiply the first equation by 2 and multiply everything in there by 2, I would get negative 2x plus 2y equals 8. And then this would mean that my y terms are now identical for these two lines. So this is still the same line that we had originally, we just multiplied everything by 2. So now the y terms are identical. And I wrote below, if you had decided to make the x terms identical, then instead you would have multiplied the second equation by -1, making the two x terms identical. Either of those is fine, just alter the equations so that either both x terms are the same or both y terms are the same. In step 3, we're going to eliminate one of the variables by subtracting the two equations from each other. So the terms that we just made identical are going to disappear. So I'm taking the first part here when I made the y terms identical. So if I'm subtracting these from each other, obviously 2y minus 2y just leaves us with 0. So those go away. We're left with negative 2x minus x, so minus 3x. And then 8 minus 5, that gives us minus 3. So we know that we did the step correctly if we've eliminated one of the variables, because now we know how to solve this. We're able to solve for x, where originally we weren't able to do so. So that's the next step, solve for the variable that's still there by isolating for it. We've got negative 3x equals 3, so we'll just divide both sides by negative 3, and that gives us negative 1. So we're halfway done our solution because we know that the x value of our solution is negative 1. We just don't have the y value yet, and that's what step 5 is. Solve for the remaining variable by plugging your answer into either of the original equations. So again, we know that x equals 1 is the x value of this solution. What's the corresponding y value for this though? And if you're thinking about it on a graph, we know that at x equals negative 1, somewhere along here, somewhere along negative 1, is where these two graphs are going to intersect. We just have to figure out what that corresponding y value is of where these two lines are going to intersect, where their solution is going to be. So you take either of the original equations, I just picked the first one, it's a bit simpler, and replace x with that value you just found. Replace it with negative 1, that gives me a y value of 3. So therefore, the solution to this system of equations is negative 1, 3. And you can always check your work by graphing it. And if you were to graph these two lines, you'd see that their intersection point is somewhere around there. We'll do some other examples a little quicker. We want to solve this system using elimination. So we write out the two equations, making sure the terms are lined up. And then we have to alter one or both of the equations so that either the x terms are identical or the y terms are identical. Looking at this, it's quite easy to make the x terms be identical if we just multiply the second equation, multiply everything by 2. So that's what I've done here. The first equation stays the same, and then the second equation, everything was doubled. Now that the x terms are identical, we subtract these two equations from each other. Those get canceled out, leaving us for the y's, we've got negative 3y minus 4y. So negative 7y. And 2 minus 16 is negative 14. Now we want to solve for y, which we can do because we just have one variable here. We'll divide both sides by negative 7. So we've got negative 14 divided by negative 7. And that works out nicely to just give us 2. So we have 1/2 of the equation, or 1/2 of the solution, sorry. We know that the y value is 2. We now need to finish the question by finding the corresponding x value. So when y is equal to 2, what is x equal to? We take either of the original equations, I just picked the first one, and replace with the variable that we just found. So we replace y with 2, and then we'll calculate for x. This would give us 2x minus 6 equals 2. So this gives us 2x equals 8, because we would add 6 to both sides. So that gives us a final answer of x equals 4. So therefore, the solution is the 0.4, 2, and you could always check this by graphing. A slightly more complicated example, but it's the same idea. Why this is more complicated is we have to alter both of the equations in order to make either the x or the y terms identical. So we have our two equations, we've lined up the x, the y's, and the constants. But based on these coefficients, we have to alter both of these. So the first equation, if we multiply that by 2, if we multiply the second equation by negative 3, it's going to make our y terms identical. You could also, if you wanted to make the x terms identical, you could have multiplied the first thing by 3 and the last one by 4. You essentially are just multiplying the equation by the opposite coefficient. So this is negative 2, this is positive 3, so that's why we multiplied by these numbers here. And you can always play around with it just to figure out what do I have to multiply these by so that we have matching terms somewhere. So once we've done this altering, we have our new equations here, and our y terms are identical with 6y. Now we can subtract them and do our elimination. 8x minus 9x, watch for that double negative, is positive 17x. And then the 6y's, those disappear because 6y minus 6y is 0. And then 10 minus 24 is the same as 10 plus 24, so it's 34. Next, we're going to solve for x just by dividing both sides by 17, and that gives us a nice number of 2. So we have half of our solution, x is equal to 2. What's the corresponding y value? We just take either of the original equations, I just picked the first one, replace x with what you just found, 2, and solve for y. So this would give us 8. We'd subtract 8 on both sides. 3y equals negative 3. Y equals negative 1. So then therefore your solution is 2, negative 1, because that's your x value and your y value. Just like with graphical solutions, we have some special cases. So if we were solving this question with elimination, we'd set it up the same way. We have our two equations. We alter the first equation so that the y terms or the x terms are identical. But once we do this, we go to do our elimination, we find that we're left with kind of a weird situation. The x terms disappear and the y terms disappear. Because when we made one of the terms identical, it also happened to make the other set of terms identical. So what we're left with is 0 plus 0 equals negative 5, which doesn't really make any sense, and we don't have any variables. So if you get to this situation, definitely check that you've done it correctly, but this is a valid situation. This means there's no solution to the problem. There's no solution because 0 does not equal negative 5. There's no situation where 0 equals negative 5, so there's no solution here. In other words, these are parallel lines. We also know that this doesn't work because it's trying to say that negative 6x plus 4y equals negative 2, but it also equals 3. So if the left sides are the same and the right sides are different, this is a problem. There's a mismatch here. There's no solution. It can't be equal to two things at once. So that would be the no solution situation. And this is the infinite solution situation. We set things up the same way. We try to make the terms identical. But when we do so, it makes the entire equation identical. So not only is the left side identical, but the right side is too. So when we go to cancel out, we get a bunch of 0 plus 0 equals 0. This is another strange situation, but this means that there are infinite solutions because it's asking us, when does 0 equal 0? At all times, in all situations. There are infinite situations where 0 equals 0. So therefore, there's infinite solutions to this problem. These would be considered identical lines. So I know that that can be a bit confusing, the special cases, and I've summarized it here. There's no solution when all the variables are eliminated and the number on the right side of the equal sign is not 0. So for example, if it says 0 equals -4, this is not true, so there's no solution. Whereas infinite solutions is the same situation, but the number on the right side of the equation is 0. So it's saying 0 equals 0, which is true in all situations, so there are infinite solutions. And if you're still confused by this, just take the equations you're given, convert them to slope-intercept form, and check if the lines are parallel or identical. We know how to do that. If the lines are exactly the same, they're identical. If the slopes are the same, but the y-intercepts are different, then they're parallel lines. So this is how you solve systems of linear equations using elimination and how we can identify our special cases.